Yeah. So, it's a.
Sharing my screen. All the Zoom people are just staring at my face the whole time. So you change the dimension of your for the this model or the. So you can change the dimension, just go back to geometry right here. Yeah. And just double click it, and then you can change the dimension there. It's going to change everything downstream, so it's going to say that you need to reload the data. That's yeah.
Yeah, take an exam. Good. Right, then give them equation. They're trying to make me things the exam coming through that. Down it for. You probably first order your company. They're very easy. They would explain that for you. Yeah.
I'll do that.
We still get to the end where you from completely. And getting it was.
All right, it's 5:30. Let's go and get started. Right, good evening, everyone. How's everyone doing today? Doing good, doing good. All right, so today, so originally I planned for us to do for today to be another frame equations day. So I had another example with frame elements. But as you can imagine from last time, it would probably take us the entire lecture just to do another example. So I'm saving you guys the torture of writing just gigantic matrices. And we're going to jump into the MATLAB stuff. And so we're going to spend all of this week working in MATLAB. So we're going to be doing a combination of reviewing MATLAB, because I know, a lot of people kind of were concerned at the beginning of class just with just how rusty your MATLAB skills are. So I want to make sure I spent some time this week reviewing that. And so we'll spend time today, we'll spend all of today just reviewing MATLAB, just making sure we're all on the same page. We know how to do MATLAB. And then on Thursday, we'll transition to, how do we actually solve our direct stiffness problems using MATLAB, right? So it's a very MATLAB heavy week. And so, today, if you want to follow along, you can open up MATLAB yourself. But for the most part today is just going to be just kind of basic tutorials. And so, I'll be kind of doing everything live here in MATLAB as well, just so that you kind of see it. And then, if you want to follow along, you can, or you can kind of watch the video later and follow along through that as well. Okay. All right, so that's the plan for this week. We're just gonna be doing all kind of MATLAB stuff. Are there any questions I can answer before we get started for today? Okay. All right, so let's get started with MATLAB. And so let me just double check to make sure that my MATLAB is open properly. Okay, it is. And the new release of MATLAB is available. I don't care. Go away. All right. All right. All right, so like I mentioned, so today we're just gonna be doing just basics in MATLAB. So we're gonna be learning how to define variables in MATLAB. That's kind of the first thing that you learn. Second of all, we're gonna learn how to set up linear systems of equations. And then finally today, we're gonna start talking about control statements in MATLAB. So that's if statements, else statements, and for loops for repeating code. Okay, so it'll very much just be a crash course in MATLAB. This is mostly just to kind of refresh your memory in terms of, how to use the MATLAB interface. But of course, I always tell people programming is like a muscle, right? It's not something that you can kind of just pick up, and you can't just, lift the heaviest muscle right from the beginning. And so it's something that you kind of have to continuously practice. And so if it's been a while since you've programmed, I would look back and see kind of maybe some of your past projects before, past things that you've done in MATLAB, trying to kind of refresh your memory on the logic, right? Because the thing with programming is that you can learn the basics, you can learn kind of the things the thing of what each line of code does, but at the same time, everyone kind of has their own unique style of actually programming. So and I think kind of doing what's most comfortable for you, doing what feels best, I think that's kind of ultimately what high level programming is all about. Okay. Okay. All right. So, this class, like I mentioned at the beginning, this class compared to EGME 540 focuses a lot on kind of the theory and the implementation of finite elements, right? And so anytime you have a class like this, where you have a course that's focuses on computational engineering, that utilizes computers to generate the results and to run the analysis, right? It's if you're going to have a proper class in this, it's really hard to avoid the program, right? FEA is a little bit special because there are such highly advanced and well-developed commercial softwares like ANSYS that are available. But if you're gonna, especially if you're gonna learn this at the graduate level, you can't really escape the program. So you're gonna have to learn the programming at some point in your education. Okay. And in terms of programming languages, there's a lot that are available for engineers to use. And so obviously MATLAB is the one that we're going to be focusing on. There's Python. Python has been gaining a lot of popularity lately, and so if you can learn Python, that's a great skill to learn to market yourself in industry. Okay. There's C++. C++ is probably the next most common one. That's more of a computer sciencey kind of language. There's a programming language called Fortran. You guys may not have heard of it, but it used to be kind of a really big thing for a while. And then, more modern languages kind of came over and took it over. But I will say that, Fortran still has its applications, despite not getting a new version since 1994, I think. People still use it because there are codes that were written in literally the 70s that we're still using today. And you'd be surprised at how many of our defense systems kind of relies on that old code. It may alarm you, but it's there's a lot. And there's also some new kind of upstart codes, and so there's a programming language called Julia. I don't know where it's at right now. It used to be kind of like I always called it the CrossFit of programming languages because it tried to become like a new thing back in like the mid 2015, 2016. But the most obnoxious thing about Julia wasn't the language itself; it was the people that used it and that told you about it at every given opportunity to tell you that they used Julia. And so, honestly, I think Julia has a lot of potential, but I think because the people who develop it are so obnoxious that people don't want to use it because they just hate the people that develop it. But I don't know, maybe it's gotten better now. But anyway, no matter what programming language that you use, they all kind of give you the same thing where they allow you to simulate real physical phenomenon by solving governing differential equations. Okay, so which language you use is not really important. It's kind of the techniques and the logic that are there. And kind of once you learn one language and once you kind of really get good, there are differences between the different languages, but there's a lot of skills. I would say maybe 80% of the skills that you learn in one language, you can transport it to another. Okay. So for this class, we're focusing mostly on MATLAB just because MATLAB is kind of the easiest one to kind of get started with. But just know that, a lot of the skills that you're learning in this class, you can take to Python, you can take to C++, you can take to Fortran. So, there's a lot of kind of, transferability. Okay. But, for this class, we are focusing on MATLAB. And so, MATLAB at its core has been designed for ease of use. Okay. It's mostly honestly built as kind of an educational tool, and it's mostly kind of programming for as kind of a step to learning kind of the more complex languages. Okay. And so performance wise, people always say that MATLAB is always really slow compared to Python or C++, which is true. So you're never going to see a very big code or very complicated code written in C+ or written in MATLAB, excuse me. Just because it would take way too long, right? And a big reason for this is that MATLAB technically is not a programming language at all. So if you look at it, MATLAB is called something called a scripting language, which for this class is not really important. It's just kind of a nice little piece of trivia, but it's not technically a compiled language like Python or C++ is. Okay. But even despite its limitations, MATLAB still has a lot of great uses. So it's really good for getting a code just up and running. And so if you have an idea for an algorithm, you have an idea for a certain implementation that you just want to test out before kind of going through the trouble of writing a C++ code or Fortran code, you can try it out in MATLAB first and then move it to the other language from there. So MATLAB doesn't have much, I would say, much performance applications because it is slow, but it still has a very important role to play in a lot of engineering, especially in the research field. Okay. And the main thing that makes MATLAB really nice is that it has a lot of built-in functions. And so it has a lot of kind of pre-made functions that do a lot of really useful things that are commonly used in engineering and research, right? And we're going to make use of some of those for the class here, okay? The other really nice thing about MATLAB, especially as an educational tool, is that it has fairly useful error messaging. And so if you do something wrong in MATLAB will usually tell you what's wrong. And it's usually fairly descriptive in telling you that, so that makes debugging a lot easier. That's not true for the other programming languages. Sometimes, if you're working in C++, you're working in Java, you'll write a code, you'll have an error, and the code will literally just say "fuck you" and then tell you to find the error yourself. But MATLAB will actually kind of walk you through it and kind of show you where the error is. So that's kind of nice. Okay. It also has very nice visualizing capabilities, and so you can plot things in MATLAB, and it looks very beautiful, very nice. We'll definitely be making use of that as well. It has very strong online support and community and a lot of documentation. Okay. And it's relatively cheap. That said, it's not free, and so a lot of the other programming languages are free. But if you compare it to ANSYS, which costs tens of thousands of dollars, it's MATLAB for $100 is a steal compared to that. Okay, so that's kind of just the introduction to MATLAB itself, right? So let's get into the kind of the basics of programming, right? So no matter what programming language that you're going to use, a core concept that you're going to need to learn is how to define variables. Okay. So in a nutshell, a variable is a labeled entry in a computer program that's used to store information. Okay. And the reason you want to store information is because you oftentimes you want to later reference it, you want to manipulate it, you want to use it in equations and so on and so forth. Okay. So defining variables, keeping track of variables and using variables is kind of a very poor idea to just all program. Okay. And so to define a variable, it's quite easy. So you basically have to give it 3 pieces of information. Okay. And so this is usually all defined on one line of code. And so on the one hand, you have the name of the variable. Okay, so you have to give each of your variables your name. And oftentimes, and you're the one that gets to decide, what the name of the variable is. And so that's nice. Okay. Next thing you have to add is an equal sign. So I don't have an arrow pointing here, but the equal sign is probably the most important part of this statement here, right? And then at the end here, you have the value of what you're going to give to that variable. Okay. All right. And so when you read this line of code as kind of plain text, what we're basically saying is that we want to create a variable. So we want to give the variable the name scalar _ example. Okay. We have the equal sign. So the equal sign is an assignment operator. Okay. And so programming, in most programming languages, you're going to use the equal sign to assign a variable, assign a value to a variable. So equal sign means assignment. Okay. And then you're going to give it the value of the variable itself. Okay. And then after you execute this line of code, or after the program executes this, it's going to create a variable with the name, with the value of 6. Okay. Okay. So let me kind of give you a live demonstration of this. Okay. All right. So MATLAB actually has a very nice way of tracking the variables for you. So if you've used MATLAB before, you're probably familiar with this, but there is a workspace here. Okay. Right. So this workspace here keeps track of all the variables that you've created in your program, and it also gives you their value, right? So you have the name of the variable as well as its value, right? Another nice thing about MATLAB that we won't be making use of this that often is that we have the command window. And so the command window is a way for you to kind of type lines of code to execute, and then MATLAB will execute them in real time, right? Typically speaking, we don't use MATLAB like this. Typically, we write a script and we kind of execute all the lines at once. But just for now, just for educational purposes, we're going to use this command window and kind of execute lines one by one. Okay. Okay, so let's look at the example of defining a variable here. So, right, so remember, to define a variable, we need to give it a name. Okay. So in this example here, I'm going to define a variable called scalar underscore example. So that's going to be the name of my variable. Okay. You can see here I'm using an equal sign. So the equal sign means I'm going to assign a value to this variable name. Okay. And then I'm going to give my variable a value. So the value for this variable is going to be 6. Okay. You can add a semicolon. Actually, semicolons in MATLAB are optional. But it's good practice so that when you finish writing a line of code, you end it with a semicolon. Okay. Okay, so I'm going to hit enter. Okay. And so by hitting enter here, it executes this line of code. So I've sent this code to MATLAB. And I said execute this instruction here. Right. So I've told MATLAB that I want a variable called scalar example. I'm going to set an equal sign. And so say what I'm telling MATLAB is give this variable a value of 6. Okay. All right, so one thing you should know is that after I executed this line of code, it created that variable for us here in the workspace, right? So in the workspace here, we can see that we have one variable here called scalar underscore example, and it has a value of 6, okay? All right, and so you can double click this actually too, and you can see that has a value of 6, so not that exciting here, but you can see here that we've created a variable and we've given it a value, right? Let me create another variable. Okay, so let me give this name another, we'll give it this variable name called another variable, and we'll say that this is equal to, I don't know, say 24. Okay. Okay. So when I execute this line of code, I'm going to hit enter. I want you guys to kind of pay attention to kind of what's happening in the workspace right here. Okay. Okay, so I'm going to hit enter, and you can see that I've created another variable and I've given it the value of 24. Okay. Okay. So that's kind of the basics of creating variables. And so, this is kind of a, and we're going to use variables. We're going to manipulate them, throughout our programming experience here. Okay. All right. Any questions on this so far? Okay. All right. So before I move forward, I mentioned I meant to mention this before, but I think I think a lot of people kind of get very naturally intimidated by the idea of programming, that it's a whole nother language, that it's tough, right? And programming is tough. And so it takes a lot of practice. It takes a lot of, logic to kind of get it done right. But I always like to think of it like this, where, when you're writing a program, a computer program is nothing more than just a list of instructions for your computer, right? So your computer, you can almost think of it as like your own kind of personal, mega calculator. It's more than just a calculator, but just for the sake of argument, let's say that it's a calculator, right? The lines of code that you write, each line of code is a separate instruction for your computer to execute, right? So think about how you kind of instruct, someone else to do a task for you, right? So let's say that you're managing inside an engineering business, and you need to tell someone, to run the simulation for you, to do a task for you, right? So the way that you would do that is you would write a set of instructions for them to execute, right? A computer program is the same thing. So a computer program is nothing more than just a set of instructions for the computer to execute, right? I think the thing that gets people cut up is that, a computer has its own language, it has its own way of kind of receiving instructions. So you have to kind of write the instructions in a way that the computer will understand, okay? And more complicated things often require, more complicated sets of control statements. And so things like if statements, for loops, things like that, okay? And so, if you think about a computer program as nothing more than just providing instructions to the computer to execute a task for you, then hopefully that kind of, makes it a little bit less intimidating to kind of learn computer programming. Okay. Even simple statements like this. And so, almost every line of computer code, there's an equivalent statement in kind of plain human speak to do. Okay. And so oftentimes I find it really useful to like look at a code and try to interpret it in terms of, how would I say this in kind of plain human speak, to kind of, determine what this code is doing, right? So for example, for this kind of very simple line of kind of creating a variable here, this line of code in human speak would be to, tell the computer, say like, I want to create a variable and I want to assign it a value of 6, right? So create a variable called scalar underscore example and give it a value of 6, right? That's all that this line of code does, right? And the only difference is that, computers don't understand English. Although with AI and ChatGPT, that's starting to change a little bit, but for the most part, computers understand, instructions in this form, right? And think of your computer program or your script as kind of giving your computer instructions. Okay. So let's move on. So let's talk about variables a bit more. So now that we know how to define a variable, let's talk about kind of what we can do with variables in terms of computations, right? So now that we have a variable, we can use it in operations, right? So one thing that you'll see very commonly and especially in scientific computing, like FEA, is to take a variable and use it in some kind of mathematical equation like this. Okay. Okay. So let's do this example here, right? Okay. So we have our example. We have our variable here called scalar example. I'm going to make another variable here. Okay. So I'm going to call it scalar underscore operation. And I'm going to show you what how this variable can use other variables that we previously defined. Okay. Okay. So first, let's start with this. And so let's define another variable. So let's define one called scalar operation, right? So you can see that we're using the equal sign. So the equal sign is an assignment operation. Okay. And what we're assigning is the value of whatever scalar example is times 3. Okay. So to evaluate this this equation here, you would basically just use algebra. And so you can say here that we have this variable scalar underscore example. We know it has a value of 6 just from other parts of the code. And so we can just plug in 6 into this equation. So this new variable called scalar underscore operation should have a value of 6 times 3, which is 24. Or 6 times 3 is 18. Excuse me. Okay. And so when we do that, when we execute this line of code, we can see that our variable here, scalar underscore operation, does indeed have the value of 18. Okay. And we can play off this again. So we can say another variable called another operation. Okay. And so let's say that, we create a little bit more complicated expression here. So let's say that we have, this is going to be equal to scalar operation multiplied by, I don't know, 2/3 minus another variable, right? So you can really make these equations as complicated as you want. Okay? So this is going to take our value for scalar operation, which is 18. It's going to plug into this, and so it's going to multiply by 2/3. And then from that, we're going to subtract another variable, which has a value of 24. Okay. And so based on the values of all the input variables, we can say that this variable, another operation will have a value of minus 12. Okay. And in fact, if we look at the value for it, we can see it right here. Okay. All right. So once you create a variable, you can use it in other equations for other variables like this. Okay, so that's totally fine. Okay. All right. So these same principles of kind of defining variables and using them in equations. Was someone talking? Okay. You can apply that to vectors as well, and so you can create variables to represent vectors. Okay. All right, so let's look at this in real time here. So let's go back to MATLAB here. Right? So I'm going to create another variable, so called vector underscore example. Okay. All right, so to create a vector here, you would use these square brackets. Okay, so an opening square bracket basically tells MATLAB that you want to create a vector, right? You're going to input the entries in the vector, and so each of the entries in the vector are going to be separated by a comma. So we have 7, 1, 4. Okay, and we have a closed bracket to indicate the end of the vector, and of course a semicolon because it's the end of the line. Okay. Okay, so I'm going to hit enter. So that creates another variable here called vector underscore example. And you can see here that if we double click it, we can see the entries in the vector. And so the first entry is a 7, the second entry is a 1, and the third entry is a 4. Okay. Right. And so you can use variables to not only store numbers, but you can store vectors as well, and as well as matrices. We'll go over matrices in a second. Okay. And just like we did with the scalar entries, we can also do operations here. So let's do vector operation is equal to, Let's do a simple scalar multiplication. Let's do 5 multiplied by vector example. Okay. All right, so what this is going to do is it's going to take 5 and multiply it by everything inside the vector. So we have 5 times 7, 5 times 1, 5 times 4. Okay. And it's going to create a new vector that has those entries there. Right. So the vector operation, once I run this code here, should have the values of 35, 5, and 20. Okay. And that's exactly what we get. So once we run this code vector operation, it took 5 and it multiplied every entry in that vector. Okay. And you can also do vector addition. So if we do vector underscore addition, okay, we can say this is equal to vector underscore example plus vector underscore operation. Okay. All right, so what this is going to do is going to perform vector addition. So we have 7, 1, 4, and then we're going to add that to 35, 5, 20. Okay. So let's see what we get from this. Right. And so by adding those two vectors together, we get the new vector 42, 6, 24. Okay. All right. So that's the basics of kind of scalar and vector operations. So you can create variables. They could be scalars, they could be vectors, and then you can perform kind of basic on an operation on that. All right. Any questions on this so far? Okay. So this is a little bit off script, and so I don't have this in the slides, but let me show you kind of a very common error that you're going to run into regarding vectors and matrices as well. Okay. So let me create a new vector. So let's say this will be 1, 2, 3, 4. Okay. All right. So this new vector variable here is a 4 entry vector. Okay. When you add vectors together in MATLAB, the assumption is that the vectors that you're adding together are the same size or the same dimension. Okay. Because if you try to add vectors together that aren't the same size, so let me create a new variable here called new operation. Okay. And we set this equal to new vector. And then to this, I'm going to try to add vector example. Okay. And so you can see here that MATLAB didn't like this, and so it gave me an error message in red. Okay. And so what it's telling me is that the arrays have incompatible sizes for this operation, right? And so what this is basically telling you is that you try to add two vectors that have different sizes, right? Because in reality, if you try to do that on paper, you wouldn't be able to do that either. Because if you try to add vectors that have different sizes, not everyone is going to have a partner, right? And so this is a very common thing in MATLAB. And so this error message comes in different sizes, and so we'll see kind of another version of this for the matrix. But I would say, especially for finite elements where we're dealing with matrices and vectors a lot, this is a very common error. So this is definitely something to kind of get familiar with, and it kind of gives you an example. It gives you kind of a hint of kind of where you should look in your code. Okay. Okay. All right. So let's you can also define vectors in other ways, right? And so not only can you use the square bracket notation to define vectors, but you can also use special functions, okay? Remember I mentioned that MATLAB has a lot of special functions that are available, right? So one function that we're not going to use it too much in this class, but it's used quite a lot is a function called linspace, okay? So linspace is a special function that creates a vector where the entries of the vector kind of sequentially count up from one end to another, okay? And so the way to use this linspace vector, there are 3 entries that you need to do. So you need to specify the starting point, you need to specify the ending point, and you need to specify how many entries that you want in the vector in total, okay? All right, so to use a function, okay, I'll write this as a comment. So to use a function in MATLAB, okay, you need to give it the input arguments. Okay. So I decided to write that out just because I didn't have it in the notes there. But if you're going to use a specialized function in MATLAB, so something like lint space, you want to make sure you give it the appropriate number of arguments here. Okay. Okay. All right. So let me give you an example here. So I'm going to use the lint space function, and I'm going to create a vector. Okay. So let's say we're going to start the vector at 0. Okay. The last entry in the vector, I want it to have a value of 50. Okay. And then I want to give this vector, let's say 51 entries. Okay. Okay. So this is how you use a specialized function in MATLAB. And so specialized functions all have special names, right? And they're always followed by parentheses. Okay? And so to use a function, you have to call the name of the function. You then have to use an open parentheses. And then inside those parentheses, you have to give all of the arguments for that function, right? Okay, so let me hit enter here to kind of show you what the result of this line of code here is. Okay. So like I mentioned, so to use lint space, first entry, starting point. Second entry, ending point. And last entry, number of points. Okay. Okay. So when I call this lint space function here, I said, give me a vector. Okay. The first entry in the vector should be 0. The second entry in the vector should be 50. And the number of entries in the vector should be 51. Okay. So let's double click this. So I created this vector called lint space underscore example. And so if we look at the entries in this vector, we can see the first entry has a value of 0. Okay. Each entry after that is counting up sequentially. Okay. And if we go to the end of the vector here, okay, the 51st entry, we can see the last entry has a value of 50. Okay. Okay, so this is kind of an example of how to use a specialized function to create a variable. Okay. So we're not going to use lint space all that much, but it's kind of a good example to use. Okay. Because another example, another function that's going to be useful to us is actually called the zeros function. Right. So the zeros function will create a vector or create a matrix. We'll use it for matrices as well that contain all zeros. Okay. So let's look at this example here. So zeros underscore example. This is going to create a vector that has 100 entries that are all zeros. Okay. Okay, so let's look at that. So the zeros function. Vector matrix. Question. Okay. So we're going to be using this function a lot because we often want to create empty vectors and empty matrices for us to fill, through our direct stiffness method. Okay. All right. So let's look at that example. So we're going to do zeros underscore example. Okay. Is equal to. So once again, you're seeing that I'm creating a new variable here. So our variable has a name, zeros underscore example. I'm using the equal sign because I'm going to assign it a value. Okay. Right. In this case, I'm going to do a special assignment. And so I'm going to do an assignment based on a function. Okay. Okay. And I'm going to use the function like this. And so I'm going to say that the dimensions of this vector are going to be 100 by 1. And so it's going to have 100 rows and 1 column. Okay. So that's how you use the zeros function. So inside the zeros function, you just have to enter the dimensions of the of whatever matrix or vector that you want to create. Okay. So the input arguments for the zeros function are the dimensions Okay. So for this example here, this zeros underscore example, I've created a variable which has 100 entries, and they should all be zeros. Okay. So if we come to the workspace here, we can see the variable that I just created, which is zeros underscore example. So let's double click this. Okay. And you can see here that we have exactly as I just described. So we have 100 entries in this vector. Okay. And they all have a value of 0. Okay, so that's going to be important for us once we kind of get to writing FEA codes. Okay. All right, any questions on this? Okay. All right, so what we've learned so far is how to create variables. We've created the variables in a couple different ways. So we've created them through direct assignment. We've created them through like a mathematical equation or operation. And we've learned how to create variables through kind of specialized functions like this. Okay. Okay. So before we move on to matrices, let's talk a bit more about how you can manipulate a variable. Okay. All right. So far, the way that we've used variables here is that, we've assigned a value to a variable and we haven't changed it, right? So once a variable's value is set, then we've kind of kept it the same. Okay. But actually, you can actually change the value of vectors. So you can manipulate its value, right? So you can use the same name, but you can change the value that it represents. Okay. Okay. So let's see an example of this. And so let's take our very first variable that we created, which is scalar underscore example, right? So right now, scalar underscore example has a value of 6, right? Okay. Let's see if we can change that. And so to change the value of a variable, by the way, I'm using comments here. I should have mentioned that earlier. So if you start a line with the percent sign, then that's what's called a comment line, and that's a line that's not read or executed by the code. And so I'm using comments here just to leave kind of notes and kind of instructions here. Okay, so to change the name to change the value of a variable, you could use an assignment operator with the same name as the variable that you want to change. Okay. Okay, so for example, so we have our variable here, scalar underscore example. Okay. So right now, this currently has a value of 6, right? So let's say that we want to change for whatever reason, we're in some point in the code and we want to change this value to 9. Okay. And so to change the value of scalar underscore example, you just have to use the name of the variable, scalar underscore example. You set the equal sign, and then you set it equal to the value that you want to change it to. Okay. All right. So I haven't executed this line yet. I haven't hit enter, but I want you to kind of pay attention to kind of what's happening on this area right here. Okay. Because as soon as I execute this, it's going to change the value of that variable right there. Okay. All right, so you can see I've executed that line of code. So now scalar example has lost its value of 6, and it's now gained the value of 9. Okay, so we've one way that you can think about it is that we've overwritten or we've overwrote the previous value with the new value. Okay. Okay. And so you can do this in lots of different ways. And again, this is kind of a core kind of operation that you're going to learn and use a lot when programming. Okay. Another thing that you can do to manipulate the value of a variable is to do an update. Okay. So this is actually very useful. And in fact, if everything so far has been kind of boring for you, this part I want you to kind of really pay attention to, because oftentimes, we don't want to completely delete or overwrite a value. We just want to add something to it. Okay. And there's a particular way to do this. So to update the value of a variable, one way that you can do this is you can use an equal sign, but you make sure to use the value of the variable inside the operation. Okay. So for example, let's use the value scalar operation, right? All right, so I think this was the second variable that we created together, or the third one, or something like that. Okay. All right, so right now, scalar operation has a value of 18. Okay. And so let's say that, we want to update this value. So we don't want to we do want to overwrite it, but we want to overwrite it with the value that's dependent on the previous one. Okay. So let's say that we want to add 6. That's a bad example. Let's add 7. So let's say we want to add 7 to the scalar operation. Okay. Okay. So the way to do that is to do something like this. And so we're going to say scalar operation is equal to scalar operation plus 7. Okay. All right. So if we read this line of code here in kind of plain human speak, we can see that, the way to kind of read this is to say that this is, the new value of scalar operation, okay, is equal to the old value of scalar operation plus 7. Okay. So the old value of scalar operation here is 18. And so we're going to say that the new value of scalar operation is going to be the old value plus 7. Okay. So let's go ahead and do that. And once again, kind of watch the left-hand side of the screen for it to change once I execute this line of code. So after I hit enter, that should equal 25. Okay. All right. And then sure enough, you can see here that once I've executed that line of code, it updated its value. So it took what was there before and just added 7, and then it overwrote the old value with that. Okay. All right, so this update notation here, this kind of use of the variable name on both sides of the equal sign, this is something that we're going to use quite a bit, especially when we're assigning kind of element stiffness matrix values to a global matrix. Okay, so definitely get used to this kind of syntax. Definitely get used to this pattern because it's something I like to use a lot for our codes. Okay. All right. Any questions on this so far? Okay. All right. So before we move on to matrices, let's talk just very briefly on how to use variables. Okay. So at this point, we've covered all the basics of creating variables, manipulating them, kind of moving them around and overriding their variable values, they're updating their values. Okay. So let's talk kind of more kind of conceptually about how variables are used in these kinds of programs. Okay. So variables are used in a lot of different ways in a program. And so, the first use is to kind of permanently store an important problem parameter. And so these would be things like material properties, geometric properties. Okay. And once these values are assigned, they typically don't change, but they can often be referenced throughout the code in later calculations. Okay. So for example, let's say that we're writing a code to simulate kind of the behavior of a circle, okay, or a disk. And so we can say that, we create a variable here to define the radius of the dish. And so we say that radius is equal to 4, okay? And then later on in the code, we may have something to reference this radius. And so, let's say that we want to compute the area. And so the area of the disk is going to be pi times radius, okay? All right. Another important use for variables is to store values during calculations, okay? And so we're going to be making use of this a lot as well, just because, throughout a finite element code, there are a lot of calculations that we're going to have to do. And so we're going to need to create variables to kind of store these values or store these solutions to use them kind of later. Okay. But the thing is, for these kinds of variables, these values are often constantly being updated. They're constantly being changed. And so just kind of be aware of that. Okay. All right, and so the last tip that I'll give you in terms of variables is to make sure that you use very descriptive names for your variables. And so if you notice, for all the variables that I've written so far, I've given them kind of a 2-word name. Okay, it's very tempting when you're writing programming, when you're doing programming and you're writing a lot of code, to use very simple variable names. So say like y is equal to 3, x is equal to 4, right? That's very tempting just because it's very easy, it's very quick to write these single variable names. But I'm telling you to kind of resist this urge as much as possible, right? Because I will, because anyone that's programmed will tell you that, the majority of your time that when you're programming is not actually typing. So the amount of time that you're actually typing when you're programming is actually very small. So it's actually only about 5% of the time. So most of the time that you're going to spend when you're programming is actually debugging and figuring out why your code doesn't work. And one thing that makes your code really difficult to follow and really difficult to debug is using single letter variable names or variable names that just are not descriptive or make no sense, right? And so, don't use variable names like this. And so I really encourage you to use variable names that are like, that are sometimes a phrase. And so the phrase will tell you what the variable is, what it's supposed to do. And then when you're referencing that in your code, you're reading your code, it actually makes it a lot easier to kind of read and kind of understand what's going on. But if you use simple, very simple single letters like this, or even worse, I've seen this before. So let's say that you want to create another variable, we'll call it XX, right? But let's say that you want to create another variable, so we'll call it X5 or X3, right? Okay. This is terrible. This is the worst way to code. And if you ever try to debug someone that codes like this, I say every time I see this, I just want to slap the person that wrote this code so hard because it makes it so hard to understand. So, don't be this person. Don't use single letter variable names. Use descriptive variable names so that you can read it and kind of understand at a glance what's going on. It'll save you so much trouble. I guarantee you. Okay. All right. And you can even be funny with it. And so sometimes if you're really being frustrated, you can use profanity in your code, in your variable names. I've done it. I've submitted work that has profanity and I've gotten in trouble for it, but sometimes it's necessary because you have to take care of your mental health while you're coding as well. All right. Any questions on this? Okay. All right, so let's get to matrices. And so, you can use variables. So we used variables to define scalars. We've used them to define vectors, but we can also use them to define matrices as well, right? And so matrices are really important and they form the backbone of any kind of code that utilizes linear algebra, okay? And so if you notice, from our direct stiffness calculations that we've done so far, we're generating a lot of matrices, right? So we have to use matrices a lot, right? And so using variables to define matrices is a really important task to do, okay? So we've already gone through this, and so I've already kind of shown you how to do this when we're solving linear systems in MATLAB. But when you're creating a variable that is meant to use a matrix, one way to do that is to use this kind of comma and semicolon notation, okay? All right, and so, to define a matrix, you would do it by defining them row by row, okay? And so, and you're writing the matrix from top row down. And so each entry in the same row is separated by a comma. And then when you want to go to the next row, you use a semicolon to go to the next row. Okay. Okay. So that's straightforward. We've kind of seen that before. Okay. Okay. Another way that you can define a matrix is to use our zeros function. Okay. And so one way is to kind of directly specify the entries in the matrix like this. Another way is to use the zeros function to create an empty matrix and then to assign each individual entry of the matrix itself. Okay. Okay. So for example, we can assign a matrix like this, right? Okay. So one way that we can make a matrix. So let me go ahead and let me clear this. Right. If you ever want to clear your workspace and there's kind of too much clutter here, you can enter the command clear all. Okay. So when you enter clear all, it clears everything in the workspace to kind of clear things up for you, okay? And if you ever want to kind of clear your command window here, you can enter the command CLC, okay? And so if you enter CLC, it's going to clear everything in your command window just to kind of give you a clean slate, okay? Okay, so enter CLC. It cleared my command window, so now we're on a clear slate. Okay. Okay, so let me show you kind of two different ways to define a matrix. So let's do the classic way. So this is the way that I've kind of taught you before for using MATLAB to solve matrices. Okay, so let's say that we want to create a matrix like this. We're say 1, 2, 3. Next row, it's gonna be 4, 5, 6. Next row, and then the last row here is gonna be 7, 8, 9. Okay. Okay, so that's one way to create a matrix. And so we can double click here in the workspace and you can see here that this created a 3 by 3 matrix, right? So we have 3 rows and each row has 3 columns, right? Okay, let me show you another way to make this. And so another way to create a matrix is to create first an empty matrix. Okay, so I'm going to use the zeros function that we talked about before, and I'm going to create a 3 by 3 matrix. Okay. Right. And so after executing that line of code, let's go ahead and look in the workspace here. And so we look at the zeros matrix example, you can see we have a 3x3 matrix, and all the entries here are 0, right? So 0, 0, 0, 0, 0, 0, 0, 0, 0, okay? From here, we can actually assign each individual entry in the matrix, okay? All right, so let me show you what that means. And so even though we're storing this matrix as one single variable, you know, each entry in the matrix itself, you know, each of the 9 entries here is a separate variable that we can actually change, right? So it's a variable within a variable, right? So for example, let's say that we want to change the entry. Let's say that we want to change the entry in the top left. And so that's going to be the first row and the first column, right? And so to change that variable, we can say zeros underscore matrix underscore example at 1, 1. Okay. So let's say that we want to change this entry to none. Okay. Okay. So it's going to be subtle, it's going to be quick, but I want you to kind of pay attention to kind of what's happening on this kind of workspace right here. Okay. Okay, so after I execute this line of code, the top left entry there should change to none. Right? Right? And so if you caught it, you know, this entry right here changed to 9. So if we double click on this matrix now, right? It's still for the most part 0. So 8 out of the 10 entries are zeros in this matrix, but now this top left entry is none. Okay. We can continue this. And so let's say that we want to change the second entry in the matrix in the first row in the second column to 8. Okay. And let me give you a tip here. So if you're programming in the command window here, the command window actually has a memory of all the commands that you entered. So if you're on the command window here and you hit the up arrow on your keyboard, okay, you can see a history of all the entries that you've created. Okay. Whoa. This is even dating back to last semester. That's crazy. It's May 5th, 2023. Wow. MATLAB never forgets, I guess. Okay. So if you're going to be inputting kind of repetitive lines of code, the up arrow is kind of a useful thing to do if you're working in the command window. Okay. Okay. But I don't want to enter the exact same line of code again. That would be kind of boring, right? So instead, let's change this up a bit. Okay, and so instead of modifying the entry in the first row and the first column, I'm instead going to modify the entry in the first row and the second column, and I'm going to change that value to 8. Okay, so once again, kind of pay attention to what's happening over here. So once I kind of hit enter right here, right, you can see that the second entry here has changed to 8, right? And we can kind of continue this again. So instead of 1, 2, let's change this to 3, 2. Okay, so there's going to be a third row and the second column. And let's change this entry to 7. Okay. And so you can see here after executing that, the entry in the third row and the second column has now changed to 7. Right. So you can change kind of individual entries in the matrix just like this. Right. And in fact, you can take a matrix that's already defined. And so you don't have to just stick with the zeros matrix. You can take a matrix that already has its entries defined and kind of change an entry there. So let's do manual matrix example. Okay. Let's change the entry in the very middle of the matrix. And so let's change the entry at 2, 2. Okay. Currently, the value of that entry is 5, right? So let's change this value to 9001. Okay. Okay. It's crazy how far memes go because over 9,000 feels like an ancient ass meme at this point. But you can see here that after we've executed this line of code, this manual matrix example, the middle entry is now 9001. Okay. So you can use this this kind of syntax here to modify individual entries in the matrix. Okay. And this is actually going to be really useful to us because if you remember, in the direct stiffness method, okay, in the direct stiffness method, there were a lot of situations where we're kind of modifying matrices on the fly. So whether it be during the assembly step where we're taking our element stiffness matrices and adding them to our global stiffness matrix, or we're applying boundary conditions and we're changing entries in the matrix to reflect either a Dirichlet boundary condition or a Neumann boundary condition, right? being able to modify selected entries in a matrix is very valuable to us. Okay? Okay. And so kind of learning this syntax is actually really useful. And in fact, this particular pattern right here, where we create an entry matrix and we assign values kind of directly into that matrix, that's something that we're going to use exactly like that in the assembly step. Okay. And so when we do assembly, when we assemble a global stiffness matrix, right? The first thing we're always going to do is we're going to create an empty matrix. And then for each element stiffness matrix, we're going to assign the values into that matrix, using syntax just like this. Okay. All right. So matrices, I know that we've kind of covered it before with kind of the direct entry, but doing the entry by entry manipulation is something that's going to be very key for us as we develop our finite element programs. Okay. All right. Any questions on this so far? Okay. Okay. And so, of course, another thing that you can do is you can apply our update pattern to this as well. So, let's say that, we have our matrix here and we want to update a value. So, let me do, let's do manual matrix example. Okay. And so let's say that we want to modify the entry on 2, 2. Okay. Right. So currently this value is 9,001, right? But let's say that we want to modify it, but we want to use its old value. Okay. So we're going to use our update notation, right? So we can apply our update notation to entries in a matrix as well, right? So we're going to have manual matrix example 2, 2 is equal to manual matrix example 2, 2. And so let's say that we want to subtract, let's subtract 1,000 from it. Okay. All right. So what this is going to do is that you're basically assigning a new value to matrix example 2, okay? But you're utilizing the old value of what was there before. So this is going to be 9,001. Okay, because that's the old entry that was there before minus 1,000, right? And then you're going to take that and you're going to overwrite that into whatever was there before. Okay, so we're going to have 9,001 minus 1,000. And so that's going to be 8,001. And so once I kind of execute this, you should see this change to 8,001 right here. Okay. All right, it was pretty quick, but you can see that the entry here was changed to 8,000. Okay. So you can apply our update notation or update syntax to individual entries in the matrix as well. And again, that's something that we're going to use quite a bit once we start to get to assembly. Okay. Okay. So this next part here, we've done this before, so I'm just going to go through this very quickly. But you can also use MATLAB to solve a system of linear equations. Okay, so this is what you guys use for homework 1. This is what you guys are using for homework 2 / ANSYS activity 1. Okay, so if you have a matrix set of equations, a linear system of equations, you can represent them in a matrix. And so you can solve this in MATLAB. So you can create variables to define the left-hand side matrix as well as the right-hand side vector. Okay. In our case, instead of the left-hand side matrix, this would be like the stiffness matrix. And instead of the right-hand side vector, this would be like the forcing vector. Okay. And to solve for the solution to this linear system of equations, you would use the backslash operator. So you would say a left-hand side matrix backslash right-hand side vector. That's going to give you your solution to this here. Okay. All right, but that's basically exactly the same as kind of what I showed you before. Okay. All right. All right, so we're doing good. So we've basically just finished kind of the basics of MATLAB. So creating variables, manipulating variables, vectors, matrices, scalars, right? So we're going to continue this on Thursday, but I wanted to kind of introduce control statements in MATLAB. So starting with if statements and then going from else if to else and then for loops. these are, somewhat a little bit more advanced topics in programming. But these are all things that we're going to use in this class as well. Okay. All right. And so, as we transition to kind of more of the advanced topics in MATLAB, I'm going to move, I'm not going to use the command window anymore. I'm going to do everything in a script instead. Okay. All right. So the big difference between using the command window and the script, and so, you can see in the command window, we're kind of executing lines of code kind of one by one, right? Command window. Right. So that's essentially kind of what we've been doing in this part of the class so far, right? When you write a script, okay, a script is basically a collection of different kind of programming lines of programming, all kind of lined up together in one kind of file, right? So when you write a script, MATLAB will not execute the lines as you write them. It's going to wait. And so it's going to wait until you actually run the script to execute the lines of code. Okay. Let me show you what I mean. And so if you create a new script here, and so to create a new script, you can go to the MATLAB console and click new script. Or I think there's a shortcut to it. It's usually Command N. Okay. Right. Let me maximize this. Okay. Okay. And so inside a script right here, you can type lines of code. So let's do some familiar examples. So let's do scalar example. For some reason, my font has changed. What the hell is up with that? Okay. Okay. So you can see here, I typed a line of code called scalar underscore example is equal to 4. Let's do scalar underscore operation is equal to 3 times scalar example. Looks like newer versions of MATLAB have this kind of smart complete thing. It's nice. I think a lot of modern word processors have it. Okay. Okay. But you can see here that I'm writing lines of code. But if you go back to the main MATLAB console, in fact, let me kind of do this picture in picture here. Okay. Right. I've started writing the script, but nothing here is showing up in the workplace because I haven't executed this code yet. Okay. And so to actually run this code, there's a button up here called run. The shortcut for this is F5. Okay. Let me go ahead and run it. We need to save this. We need to save this code. Wow, it saves my code back from 2023. Wow, that's last year. So let me save this as 541 spring 2024 MATLAB tutorial 1. Okay. Oh, I can't start a file name with a number. So EGME 541 spring 2024. I'm only doing this just because it looks like this computer saves all my code for all of eternity. So I want to make sure I name it correctly. Okay. All right. So now that I've saved the code, I'm going to go ahead and run it. And then what you're going to see from here is that MATLAB is going to execute all lines of code in this script here. Okay. So once again, kind of pay attention to the workspace. And so you're going to be able to track, what lines of code are being executed by looking at the workspace there. Okay. All right, so I'm gonna go ahead and hit run. Okay, so you can see here that it executed both lines of code there. So it first created a variable called scalar underscore example, and it created that as a value of 4. And then it created another variable called scalar underscore operation, and it gave it the value of 3 times scalar example, which is 12. Okay. All right. So let me change this code here. So the nice thing about writing in a script is that you can change one line of code and then it's going to update everything else. And so if I change the value of scalar underscore example to 5, you're going to see that it's going to update these values here once I hit run. Okay. And it's going to look like it's going to update both of them at the exact same time. So I'm going to hit run. Okay. And you can see here that it changed both the value of scalar example to 5, but because the value of scalar operation depended on the value of scalar example, it also changed its value. So it's going to be 5 times 3. Okay. All right, so let me do it one more time just because it's kind of fun to do. So I'm going to hit number 7 here. So once again, I'm going to change the value of scalar underscore example. I'm going to run the code, and then it's going to update kind of what's happening here. Okay. All right. And so, when I run the code like this, it looks like it almost seems like, all this is kind of happening at the same time. So it's all happening kind of simultaneously. But that's not actually true. And so, the way MATLAB works is that MATLAB will read your code from top to bottom. Okay. And MATLAB actually does execute your code kind of one line at a time, and it executes it from the top going down. Okay. So for this code right here, right? So for this code right here, you can see it executes this first line of code. So it executes scalar underscore example. Okay. So it sets its value to 7. And then it executes the next line of code, which is scalar underscore operation, which is 3 times scalar. Okay. And so, MATLAB runs, for what we're doing, MATLAB is going to run pretty fast. And so it's going to seem like it does it all instantaneously. But MATLAB actually is reading your code from top to bottom. So it executes the first line first, then the second line, the third line, and fourth line, all the way up until, line 100 or such and such. That's why you can change a value here, right? Right. So if I change it to 10, right? And when I run this code, it actually updates the value of scalar operation, right? Because it reads the code from top to bottom. Okay. Okay. Right. But keep in mind that, because it reads the code from top to bottom, if you write any code after this, so let's say that we want to update the value of scalar underscore example. So let's say we want to update this to be 12. Okay. All right. And so this is a very simple kind of 3-line code right here. Okay. And so you would think that, if we update the code like this, if we update the value of scalar underscore example to 12, that should update the value of scalar underscore operation, right? Because scalar underscore operation is 3 times scalar example. And if we update the value of scalar underscore example to 12, then you would think that it would update this as well. But let's run the code here to kind of see. Okay. Okay. And so we ran the code. And if we look at our workspace here, it kind of seems like we have an anomaly, right? And so we have our scalar underscore example, which is 12, right? Because we updated it. And so it started at a value of 10, and then we updated to the value of 12, right? And so since scalar underscore example was 12, that means scalar underscore operation should also be 3 times 12, which is 36, right? But that's not true. And so, what we can see from the workspace here is that scalar underscore operation has a value of 30. And the reason for this is that, MATLAB is going to execute your script from top to bottom. Okay. And so the way MATLAB read this code was that it read the first line, which is scalar underscore example. So it said, all right, I'm making a new variable. I'm giving it a value of 10. Okay. Then it read this line of code, which is scalar underscore operation. So we said scalar underscore operation has 3 times whatever scalar example was. Okay. And so it said, all right, I need this variable scalar underscore operation. I have this line of code up here. I know what scalar underscore example is. That's 10. Okay. And so scalar underscore operation is 3 times 10, which is 30. Okay. And then it reads this line of code right here, which is scalar underscore example, which is 12. Okay. And so MATLAB reads this and said, all right, I'm updating the value of scalar underscore example is 12. And so that's how it's there. But we never updated the value of scalar underscore operation. And so if we wanted the value of scalar underscore operation to update as well, then we need to repeat this line of code right here. Okay. And so by changing this, by adding this update line down here, you're going to see this update to the proper value. Okay. All right, so running this, you can see here that, now that we've included the update operation there, both variables are updated. But without this, right? Without this, MATLAB is only going to update the value of the first variable, but not the second. Okay. So this is a really important point when you're writing scripts. And so MATLAB will execute And but if you want to update the values, was so MATLAB will not update a variable unless you tell it to. So in this kind of very simple example here, even though we're using the scalar underscore example variable, right? MATLAB is not going to update the value of scalar underscore operation unless we explicitly tell it to. Okay. So that's kind of a very important point, and I'm kind of taking a detour because this is not in the slides, but kind of what I've kind of noticed in the past about using MATLAB is that this kind of subtle piece of information I think kind of gets lost on people. So I want to make sure I kind of mention it now, just because this is especially relevant once we start writing kind of very long and complicated programs with hundreds of lines, and so you want to make sure you kind of understand this philosophy right here. So as you're debugging stuff and as you're wondering, why certain variables are not updating, you need to do so kind of explicitly in the program. Okay. All right. Any questions on this? Okay. All right. So we have about 5 minutes left, and so I think that's it's a little bit too short a time to introduce if statements. And I kind of wanted to end today right before if statements anyway. And so we'll leave if statements to next time. And so we'll pick up this example on Thursday when we come back. And we'll learn about if statements, else if statements, else statements, and for loops. And so it'll be a grand old time of more programming and lots more examples. Okay? All right, so thank you guys for coming today. Hope you guys enjoy the rest of your evening. Hope you guys enjoy the rest of your day. And I will see you guys Thursday for more MATLAB.
Oh, in the previous class video. Well, I took 4 times, but that's. Oh, no, well, probably. Why, do you have a question? I said, possible ways. Well, I've never done the parade stuff. That you can see. Yeah. Yeah. Well, the beat one's not that bad. It's technically one thing. Yes. And then scroll down. That one is good. Yeah, the frames. Yeah, that seems like it's gonna be challenging. Well, not challenging, but